Thank you for coming to Adventures in Elm. Elm is a programming language that runs in the browser. It's pretty hot and trendy lately. I'm kind of excited. In this talk, we're going to journey from Hello World to an actually kind of useful application, which is pretty neat. Along the way, you might get excited about Elm the way I am. Even if you don't, I think you'll learn something that you can apply to all your other programming languages. Elm taught me several principles that have changed the way I evaluate languages and my own programs. And we'll get to kindness and reproducibility and events as we go along. The biggest one was the part that I can do UI programming at all and not hate myself. Because I'm a backend developer and consider myself a functional programmer, I really like my functions to be like repeatable and data in and data out and highly testable and stuff like that. And Elm gives me all of that in the UI. And when I first heard that, I'm sitting next to my friend Richard at a wedding, and he's talking about Elm and he's excited about it, and I'm like, user interface programming without side effects? Because my UI experience is in Java Swing. And there you set up all the event handlers, and when somebody pushes this, you try to update all the bits that are relevant to that, and it's just like this snarly nightmare of side effects and of UI updates and responding to that. It was chaos, and so I was skeptical. But Elm really does this. It's a little bit like Stripe. So I work at Stripe, and at Stripe we abstract the payment system. So we take this really snarly, trust me, it's super nasty, concepts that consist of the financial system and how payments work, and we put a clean API on top of it. An API that's highly testable, that's well documented, that's fully backwards compatible forever and ever. And we do this to make your life easier. It doesn't make our life easier. But Stripe has worked hard to solve that problem. Elm is very focused on solving the problem of writing applications that run in the browser. It's one problem. It's a very common problem. But by restricting itself to that, Elm is able to make a very clean developer experience that's also entirely data in, data out. Elm is not a JavaScript transpiler. Okay, you've got ClojureScript, and you've got Scala.js, and you've got TypeScript, and the others that output JavaScript that you can then use from your JavaScript. Elm is not that. It is a different experience. Yes, it technically creates JavaScript as output, but that's an implementation detail. When WebAssembly is a thing, it'll use that. It looks more like this. So your Elm code only runs within the Elm runtime. And the way it's able to do the functional programming and still make a user interface is that my Elm code outputs data, which is the description of how I wish the browser looked right now. And then the Elm runtime figures out the most efficient way to execute some JavaScript, to interact with the DOM, to make it look like I want it. And then when the user interacts with it, that comes back into event handlers and blah, 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 which Elm translates into data, which is a message that becomes input to my code, which then comes around and outputs what the view should look like now. And then Elm makes that happen. So all the nasty side effect coordination thingies are in the Elm runtime. And Elm has gotten more and more specific about how we write code, and it's streamlined this experience as the language has grown until it's really quite pretty. Elm says you will program asynchronously. Everything will be asynchronous. It's all event-driven, as opposed to JavaScript, which is single-threaded and imperative, and it turns out that this can be a lot simpler. Now, it means that we tried to program Elm for Screeps, which is some game that you write JavaScript programs in to tell your minions what to do. Can't do it because Screeps needs single-threaded and imperative, and Elm is only able to run in its own asynchronous event-driven architecture. So limitations that also make our lives a lot easier. Elm says no to a lot of things. There are no statements, there are no side effects, there are no runtime errors. You can have bugs, but not errors. You will never see undefined is not a function, or property blah-de-blah not defined on blah-de-blah. And this is wonderful because this is the kind of nightmare that drove me away from JavaScript over and over. Oh, I'm a Java programmer, I can program JavaScript. No, because I can't handle this. But this is a nightmare that never happens on Elm Street. Right, so the trade-off there is you don't get any runtime errors, your users don't get the surprises, but you have to deal with all the compile errors. In JavaScript, you can like write something and you can see it in the browser right away. And in Ruby, you can write something and you see your green tests and your green tests. And in Elm, the definition of progress is a different compile error. But that can be handy. I can do like compile error driven programming. And this is where the kindness comes in, because Elm has some relation to Haskell. The syntax is kind of based on Haskell, but the attitude is not. Elm is really kind in its compile errors, and it wants them to guide you. And Evan, who writes Elm, goes way out of his way to make the compile errors friendly. So let's get some compile errors. That's the best way to do it. Here's an empty directory, and I can start by creating the simplest Elm module that I can think of. Of course, we'll do hello world. You have to name the module, and you have to tell it what methods are allowed to escape. Elm is extremely explicit about these things. And say I just want to do hello world. That should be good. I'm using the Atom editor here from GitHub and the Elm language program package by Eric West. And then just all I have installed here is Elm itself. So I'm going to Elm make, and make means compile. It doesn't actually mean build. So when I run Elm make, it says, oh, hey, by the way, you haven't specified like your version of Elm and all these other packages that you're definitely going to need. So how about we do that? And it's very polite and asks me. And I say yes, and it starts downloading, and it doesn't cache any of this, unfortunately. Now we have our first compile error. And it says that it needs an HTML or an SVG or a program in order to render on screen, but you gave me a string. Okay, but it gave me something to do. It's like, oh, well, I can pick one of those. Well, I'm trying to output static HTML to start with, so I'll pick one of those. So what I actually want is html.text, and I'm going to need to import HTML. Oh, dang it, I don't have my build script yet. Okay, just for now, I'll make. Okay, so now it has outputted some stuff, and I have my Elm program that I made. I have Elm package.json, which is where it's defining what version it's using and all its dependencies and blah, blah, blah. You do put that in version control. Elm stuff is the build output and all the packages it's download. You do not put that in version control. And index.html is the output of the compiler. Elm has said, I'm going to give you the fastest way to something you can open in a browser. So if we open that, we get, yay, hello world. Okay, so moving on from hello world, I want to tell you about the app that drove me to want to do UI programming at all. Because as a backend developer, now and then it would be nice to be able to make the programs that I want, which in this case is an architecture diagram that I can put labels on, and then I can like zoom in and put in more labels and zoom in and put in more labels, but it has to be infinite zoom. Because no tool out there, including Prezi, including a lot of the other ones, no tool out there lets me zoom in deep enough to diagram the infrastructure architecture at Stripe. Not even close. So that's what I want. Now today we're going to build part of that app. We will not get to zoom. Zoom is hard. But we will get to putting labels on the screen. So that'll be cool. Okay, so I'd like to build these things up incrementally. Like I can start from the static page and see if I can get it to look kind of like what I want it to look, and then worry about interactivity. So in this case, I want to start with a main element, and most of the elements in the Elm HTML module, it's main underscore because main is a keyword, have a list of attributes followed by a list of children. So my main element is going to have no attributes, but it's going to have a child, which is a canvas, which has no children, but it does have some attributes. And I'm going to need HTML attributes.style. Oh, okay, this is totally not fair. I forgot that it is totally not fair to like put this much code on the screen without telling you the syntax. So Elm syntax in 5 slides. You declare an identifier with the name of it, and then equals, and then some value. Everything in Elm is an expression. The definition of your identifier, including functions, is always exactly one expression. In this case, it's a literal string, hello world. I could also give you a list of literal strings. Notice the square brackets are a list literal, and there's commas between the list values, the list elements. Type declarations are optional because Elm will do type inference for you. I usually, when I get a compile error that is confusing to me, I'll go add these until the compile error tells me exactly where my problem is. So in this case, hello gets a colon right before its equals declaration. You get the colon one, and that says it's a string. Words here is a list of strings. List is a type with a parameter. Elm does have parameterized types, and so you have to tell it what kind of list this is. A list can only hold one kind of thing. One, you have to make a commitment. It cannot be object, not a thing. Any, not a thing. There's no null. You have to like say what you want it to be. In a minute, we'll see how to put disparate objects in a string. There's another type parameter coming up. So right now, our main is calling the text function in HTML module and passing it this string. Note this that in function application, there's no parentheses or commas or anything like that. It's just space. Function name, space, argument, space, argument. The type of this is HTML never. HTML has a type parameter, and that parameter means the kind of data we can get back when the user interacts with the stuff we put on the screen. Well, we just put some text on the screen. I'm not going to interact with it. It doesn't do anything. So I'm never going to get any data back from the user for that. So I can use the never type, which is the type with no like instances. So this says HTML that never gives me a message back. That text function is implemented in the HTML module somewhere with a string argument parameter, and blah, blah. I didn't put the implementation in there. But the type of it is a function type, which looks funny if you've never done Haskell. But that little arrow thing indicates a function type, and it means, okay, this is a text, is a thing that can take a string and give you an HTML of something. We usually call it message. Later, we'll use the style function, which here's another function declaration. So this one accepts a list of tuples of a string and a string. So it's strongly typed within the tuple. Well, as strongly typed as string is. And this gives you an attribute that you can, of whatever, it doesn't care what parameter it is, that you can use with that HTML. You can create your own types. There's two ways to do that. One is with an alias. So here I'm just giving another name to the record type that is a record with a field called URL and a type of string. So these correspond closely to JavaScript objects, except they're strongly typed. You can never access a property that you haven't guaranteed is there. To instantiate that, so I can say that my starting model, which is what we call the application state in Elm, in the Elm architecture, is of type model, which corresponds to that record. And I can say, okay, in this one, the URL is cat.gif, which unfortunately is as close as I get to cat pictures in this presentation. The other way to create a new type is a union type. And this is an or kind of thing. So I can make a new type message that is either the constant no-op or the constant button pushed or a got input thing that has a string along with it that's carrying some data of type string. That got input becomes a constructor, so if I want to make one of those, my input can be a message, and I'll use the got input constructor to wrap up this string, and then it's going to be of type message, and then I can put it in a list with things that are no-op or button pushed or other got input messages. To pick that apart, we'll use pattern matching and decomposition. So the update function is very important in the Elm architecture. It says, hey, I got a message, got some data from the outside world, and I got the old version of the model, the application state, and my job is to change that application state and output the new one. And it does that by matching the message. It can either be the constant no-op, I just didn't show it matching button pushed, or it could be got input, and in the got input case, I get the S out of it like this, and then I can say, last piece of syntax here, that I want to return the old model such that the URL now has the value of S. Okay, that is almost all the Elm syntax you'll see today. And we will get back to our program. Okay, so now see that style function, there it is, and I'm going to pass it a list of tuples of string, background image, to another string, which is going to be a URL of the architecture diagram that I want, And I'll define that up here. It's going to be elmview.png. Okay, let's see if we can get this working. First, okay, I can't stand like going any farther with this. I'm gonna, until I like put the source in the source directory. And also I need to bring in some CSS at this point. And if I let the Elm compiler output index.html, then I don't have control over like the CSS or anything like that. I actually want it to output JavaScript, and I want to provide the index.html that links to a CSS file under my control, and then I can just bring in its JavaScript, and this is fine. So that the compiler has this option, but I've reached this point pretty frequently, and oh, I just threw out an Elm module. Oh, now I want it to be like organized. So I have a program for that. Jessitron, Elm rugs. Organize. All right, so now I am using a tool that was open sourced last weekend. Very new. This is by Atomist, and Rug is a runtime and some libraries for code that modifies code. So I've got a little script in the Rug DSL that tells it, okay, move the main module over here and change its module name to main, and bring in a reasonable index.html and some styles, and tell package.json that the source is in the source directory. Oh, and bring in the get ignore, and there's my build script that I keep looking for. So now I have all that stuff I need to add, and then I can commit, and now I can build, and now I'm happy. Except, okay, so the first thing I did is I didn't add that import. This happens to me often enough that I can actually parse the output of the Elm compiler, look for this no module called blah-de-blah, and use one of my little programs, add import, to add the import to the file, and there. So this is completely independent of any text editor. This is just command line programs that let me evolve my Elm code. And now it should, well, it's not going to build because I think I'm going to have another compiler error. But that's OK. They're friendly. OK. Now we have my favorite one. This is my favorite one because a long time ago, I submitted an issue to the GitHub repo wherein Evan says, please tell me when your compile errors are confusing. Because if you get a compile error and you don't know what to do, that's not you being stupid. That's a bug in the language. I think that's actually a Jose Valim quote. But Evan has the same philosophy. So I used to get this a lot, but since I don't use Elm every day, I'd be like, oh, what is string concatenation? And I'd have to look it up. And Evan was like, oh, yeah, you're right. That's super common. I'm just going to give you a custom case in the compiler to tell you, yeah, it's plus plus. And I was like, wow, now I feel like I've contributed to the community by complaining. OK, oh, it's now in source, main.elm. Very good, very good. Oh, and I need to copy in my resources, too. So I'm totally cheating. Copying in pictures, that's not cheating. But copying in CSS is totally cheating because that is the hardest part. In Elm, you totally don't have to use JavaScript. I never drop to JavaScript to debug. There I've got my pictures and my styles. I never drop to JavaScript to debug, and I can get away with pretty much not knowing JavaScript, at least for a program like this one. But you do have to know HTML and CSS. And funny story, so Elm used to be, it's actually named after the word element, which you were supposed to like to find things that are to the left of other things and below other things, and generally be like easier conceptually than CSS. But it turned out people didn't want something easier than CSS. They just wanted CSS and HTML, because that is the standard in the browser. And Evan said, OK, this is what people need. I'm going to give it to them. Elm, its principles are really based on our experience of using the language, not on what Evan thinks is right. OK, let's see if that worked. Oh, I need to open target.html because now it's where it belongs. Oh, good, we have our architecture diagram. OK, this is the architecture of this application. And there's our main function that returns our little data, and not pictured as the Elm runtime. This is all working in the Elm runtime, but that goes into the view, and here's us looking at it. All right, so next I want to put in some labels. I want to label one of these things. To do that, I need to add something else to my main element. Let's have a view component that draws the labels. And I'm just gonna like pass in a hard-coded label. We'll give it text is, let's see, one of those things was the main function, and now I'm totally going to guess something. We'll give it an x of 200 and a y of 400 and see where that winds up. So I'm hard-coding a sample label while I've got a static page. And I could like give that a type. So I could type alias label. It is a text string, an x, which is an int, and a y, which is an int. See, you can totally have no errors in Elm, but you will still get bugs because x and y are both integers, and I mix them up all the time. Now, when I hit save here, we're actually, it's activating Elm format, which is a tool by Aaron Vanderhall, which says, thou shalt not argue about spacing. I mean, Elm is white space sensitive, so tabs are a syntax error. We got that over with. But there's still like arguments about should it be 2 or 3 returns before a function? And Elm format says stop arguing. And I really like it because I just type crap in and then it like lines it up and makes it pretty. Okay, so in our case, we want to draw some labels, and we're going to get in some labels, which is, and this is where like stating the type helps me figure stuff out. We have a list of label, and we want to output some HTML. HTML never in this case. And yeah, so we've got our labels, and what I want to do is like, okay, we can output a div with no attributes, and the children are going to be, we're going to map some sort of function that formats one label over this list. Now you'll notice that list is a monad. Elm has monads as they're useful, like list and maybe. It does not have the generic monad. And this makes me super happy because the code is super explicit. If you see a function call in Elm, you can tell exactly what code is going to execute based on the imports, and that's about it. And the qualification of the function name, because there's no polymorphism, there's no dynamic dispatch, there's no implicits. It's super simple. This is a little more typing for me right now, but future me loves it. And as the maintainer of a legacy Ruby application with a lot of magic, I think this is totally awesome, and I love typing. Okay, so I didn't put this let expression in the syntax. I guess I could have. Everything is an expression, but you are allowed to give more names to things, so I can put some declarations in here, and I can say that the format label function takes a record. I can decompose it like this with text x and y, and it is equal to this thing in my cut and paste buffer, which is this. So I want to make an HTML label with an absolute position so I can say exactly where it is, and then it has some text in it. That's about it. And here I've hard-coded a label. This will probably work. And if it doesn't work, the compiler will be super friendly. And I like doing code demos where one of my objectives is to show the compiler errors, because every time I mess it up, it's, ooh, look, a compiler error. Why, yes, I did actually want html.html there. That's a module HTML.type HTML, which is annoying, so I'm just going to specify that that's available. Okay, we built it. What does it do? Does it put a label on there? It does. Ooh, don't zoom, Jess, that messes it up. Okay. This screen is totally big enough to read that, I think. So yes, now we have a main, and we show this to like our peeps, and they're like, oh yeah, this is fine, this is good, let's make it interactive. And I'm like, all right, let's make it interactive. Elm is fun for that. So to make it interactive, I need to like receive, I want a text input, right? I want an input field so I can type the label instead of just hard coding it. Great. The first thing I need to do is I need to have my main function output a program instead of an HTML. I've got a program to upgrade my program. Elm Rugs upgrade to beginner program. The beginner program in Elm is a little simpler than the full version. It says the only data that we're going to receive back and respond to is stuff from the user directly interacting with the components we created, so with our text our text input that we're about to put on the screen. Okay, so the editor, it always like fills out this provenance file to like give itself credit. And then we can see that our main is now a beginner program. And this model stuff, here we have an empty application state, and we've got an update, and the only message we can receive is no op, and in the case of no op, we do nothing. Yeah, and that's like straight out of the Elm tutorial, but I put it in my little editor so that I don't have to remember it over and over. And I'm going to commit that. And this is, I can update the diagram to show our new architecture. And we can do things like, now our view, everything that was in our main function is now in our view function, because it's the view's job to output the HTML data structure of what it should look like. So now, instead of hard coding the label down here, I can just pass the model. I can pass model.labels because we have a model now. And then we need to put that in the model and say, hey, the labels are this hard-coded thing. We'll just move it up there. And then we have to put it in the type. The labels is a list of label. That'll probably work. So that's just a refactor, except that I changed the diagram. But now we have the possibility of receiving messages from the user. So here's our new architecture. We now have an update function that gets, we've got an initial model that gets passed into our update function along with a message, if a message comes in. And that model that's output every time, well, not every time, but whenever Elm decides it's time to update the screen, it's got all kinds of performance optimizations. It gets passed into our view function, which says what it should look like. And then our person, when we put some interactive inputs, can click on stuff, and those messages will come back around to our update function. Okay, so now we want an actual text input. When we add a text input in Elm, it's a little interesting. Because when it comes time to like save the label into our model, the only way we can have access to that is by having it in our model the whole time. Because I can't go query the DOM to say, hey, text input, what's in you? That's an operation that only the Elm runtime can do. So what I do is on my text input, every time we type something, we're going to get an event. New label. And every time we get that event, we're going to update a field in the model. So I need to add a field to the model in the model type, and I need to add a message and the case statement, no, not whatever, the thing, the match clause and the case statement in the update function to handle that message. And I also need like a little function that ties that together that I can then put in my view. So my editor does that stuff. Let's see if I remember to commit before. I don't think I did. Yeah, so we have a new model field, new label, and we have a new label string message now. And we're going to respond to that in the update function by changing the model field. And this is all standard stuff that I do every time I want a text input. And there's a function. So all I have to do is call that function in my view, and then I'll have, we'll be able to see the text input. So, oh, but I need to put it somewhere, right? New input label, and we give it the model. So this is going to be someplace dumb. Oh, I have to build. I could set up like some JavaScript tool chain, but I like not having to do that. That is the wrong name of the function. It's new label input. Come here, new label input. Refresh. I didn't build, did I? Okay. There we go. Okay, so we put it down here, which is like way not where I want it. That's like not where I want it. Okay, so I need to decide where to put it. For now, I'm just going to hard code something. In fact, I'm going to totally cheat and copy this. In real life, I would put this in a function, but cut and paste is going to totally work for today. And we will put the top at 200 and the left at 400, and we'll be happy with that. Because someday I'll be able to get that out of the model, but not yet. Okay, we have a text input. Great. We can type in it. Now, the cool thing happening here is actually over here. This is the Elm debugger, which I added like --debug to my Elm make and my build script, so it always puts this up, and it's like having a custom debug tool for your app every time. So here is the current context of my my application state, the whole model is right there, and I can collapse and dig around in there. And this is every message my program has ever received. And I can even click on old messages, and poof, look, here's what the model looked like when that message was processed. And here's what the screen looked like when that message was processed. So you can totally look at your application state and the view at any point in the past. Really cool for debugging. All right, but now, of course, I want to be able to like hit enter and have that save. The onInput event is like built into HTML events. Unfortunately, onEnter is not. You have to like listen to like keys down and, oops, I need to get that a parameter. Enter message. You have to like listen to keys down and like decide whether it was key code number 13, and if so, then you want to send this save message, and if not, you want to send no op, because you don't want to do anything. And that I totally copied this function out of the tutorial, but now I don't have to remember it anymore because I put it in an editor. So now we have this onEnter function that responds to key down and does some like JSON decoding, blah, 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 and looks for number 13, whatever. OnEnter, please send save label. Oh, and actually, when I send that save label message, which my editor also added for me because it knew I was going to have to send something, I would like to send the content of the label that I want. So this is going to be model.newLabel because that's its content, and we have x is 400, right? And y is 200, whatever. Okay, and then I'm going to get a compile error because I just changed the code the way I wanted it to be, and now Elm will step me through every place else that I need to change, which starts with putting a dot right there. And it's going to tell me that save label is not a function, but I'm giving it an argument. Well, I want it to be a function, so now I know to go to the declaration of save label and tell it that it needs a label, and then I'm like, okay, compiler, I know I need to change something else. What is it? Ha! Right here is the only place that we use save label, and so I give it a label, and I can say, hey, model, when you get that label, your labels should be this label prepended to old labels, and also let's say that that new label field should then be empty. That'll probably work. Okay, so I use my little editor to remember some pieces. Now we have this, and what happens when we type in it? Aha! Can you see it back there? Ha! It is totally like putting the label behind my text input. So it's saving it, and that's pretty great. Now, if only I could save it to different places. To save it to different places, I need to like some interactivity from the user. I really want the user to be able to click, and then we'll put the text input wherever they clicked, and that'll be way more useful. But to do that, I need more than just interactivity with that input I just put on the screen. I need a sort of general browser event. And this is a piece of the outside world that is not available to an Elm beginner program. So it's time to evolve our program further into the full Elm architecture. And the full Elm architecture, the difference is twofold. Upgrade to program. The difference is twofold. We can send commands to the outside world. So we can like do things like make HTTP calls to the server, very handy. And also, we can receive events. Those events, every time we make a command to the outside world, that's going to have some sort of message result that comes back to us of our message type. But also, we can subscribe specifically to general browser events like clicks. So in this case, we really want that subscriptions element. So we move up to an Elm full program, and we see that we've added, instead of model as the beginning model, we have init, because we also have the option of declaring commands that we want to send out on startup, like fetch this stuff from the server. And we have subscriptions, and that's going to be useful. And our, so our init type has changed. And now, in addition to the starting application state, we return an empty list of commands. And our update type has changed because every time we get a message, we have the option of sending something out as well. And then every case in every match clause in our case statement in our update function now also outputs an empty list of commands so that the types all line up. And we have some empty subscriptions, yay. Okay, so now that we have this, well, I can update this, I guess, but the first thing we want to do with this format is react to mouse clicks, which involves importing the mouse package, subscribe to clicks, with a K. This is another thing that I do often, so I've automated it. We're going to import the mouse package. We're going to add a subscription to the mouse clicks, and then when we get the click, we have to wrap it in a message. So we need to create a message type, and that message type will hold the click position. And so we need to put that in the model. So we need a model field for that. So all of this is encapsulated in my little editor here, and we can see Elm package.json changed. I always forget that one. Oh yeah, and we imported the thing. That's useful. New field here. New field there. New initial value. Oh, and also, since we don't have a label, stop having that hard-coded one. We can make our own now. Since we don't have a last click to start with, we've made it a maybe last click, a maybe mouse position. And so we start out with nothing. And then in the update, we say, ha, I have just this last click right here. So that's very type safe because there is no null. Now that we have a last click, we can move our new input label around. We can check it, and either we have nothing, they haven't clicked yet, and this is great, we can just output an empty div so we won't have a random text input hanging out. Or we have a just mouse position which has an X and a Y. Okay, and then we have a real X and a real Y here. Okay, the Y goes in the top, and the X goes in the left. And these are easier to figure out. All right, so now our input should be where we click, and only when we click there, and not nowhere before. Ah, it's already there. Oh, I didn't build. Phew. That always helps. Oh, and here it's going to download the mouse dependency because that's a new one. And it's installing mouse 1.0.1, but it knows and will declare that it can use any version of mouse up to but not including 2.0.0, and that's because the Elm package manager enforces semantic versioning. So the Elm package.json looks like this, and you say Elm mouse is like, I know 1.0 will work and anything up to 2.0 but not including, because if the publisher of the Elm-lang mouse package decided to change the type signature or remove any exposed methods, they're physically unable to publish that as version 1.1 or anything less than 2.0. Semantic versioning is enforced at publish time, so you can't break my compilation as long as you're in the 1.something range of the Elm package. And this is really useful when you have transitive dependencies that are common. Elm can find some place in the middle of the range that's compatible. And if not, if the ranges don't overlap, it won't let you import both those dependencies. It's very particular about that and saves me some errors, so I'm happy about that. Okay, we got the mouse, we built the thing, is it gonna work? Okay, here's our new architecture. Look. Right here, this is subscriptions. Yay! Enter. Ooh, it saved it. Now let's go over here. Aha! This is the main function, and it saved it, but it didn't delete the input. We should make that work. Let's try that. This is the update function, and this is init, and this is the world, and this is a person. Yay. Okay, now check this out. Here's our history. Here's every message we've ever received in our interaction with this app. It encapsulates everything I did and anything that came in from outside, like clicking. When I click, click, we're gonna get more messages. Where'd it go? It went back there. Okay. I can export this. Say I found a bug. Like my bug was, hey, that stupid input field, it doesn't go away when I hit enter. It keeps covering up my stuff. Okay, export. Do it. There we go. History 97. All right, let's go fix that bug. And what we want is when we save the label, we want it to ignore the last click now. Last click equals nothing. And then we'll build. And then I can come back here and I can refresh and I can import that history. And bam, I have reproduced what happened everywhere. And the last event in there is in fact a click, so it's right that that's up there. Let's see if this is still working. Messages, go here. Oh yes, okay. I misspelled messages, but that's all right. What matters is that text field went away. So I can get a bug report from someone and say exactly what situation they got themselves in and exactly how they got themselves in that situation, which is spectacular. And then I can make a code change and try it again. And if my message and model types are still or my message types specifically are still compatible, Elm will just run the same input through a different program, and you can check out the differences in behavior at every point in time, because I can click back here and back here. This is reproducibility with events, and I also find it extremely kind. Oh, there's one more thing that this doesn't do that it really should, and that is, I don't know if you can tell, but when I click over here, I kind of have to click again to get the focus in the box. And you might say, oh, Jess, just set autofocus equals true on that field. Well, trust me, that only works once. It works the first time you click and it doesn't work after that. What I really need to do is just call a tiny bit of JavaScript that says, hey, set focus. But of course I can't do that in Elm. Oh no, we keep very clear boundaries. And all side effects are expressed as data that go out as commands. Okay, but fortunately we have a full program so we can add commands, and there's a function that I totally copy out of the documentation about this, but of course I have encapsulated that in an editor. So I want the focus command now. And the focus command is going to give me a function that'll give me a command that I can send out so that when we click, it requests the focus on that field. And every command has, every command leads to a result. So it's asynchronous. My message goes out, the JavaScript does its thing when it does its thing, and it results in a message coming back to me. And when I create the command that I'm going to send out, I also have to tell Elm how to wrap the results of that command in messages that I can understand and have declared. So let's go look at that request focus command. Whee! All right, dom.focus is the magic of knowing how to call the JavaScript. And then we have to attempt that task, and it gives us a result that might be okay, that's fine, send me a no op, or it might be an error if I passed it a field ID that it didn't find. And so I can wrap that in a message of my own creation, and that message will result in nothing, no change, but I'll be able to see it in the debugger, so I'll know if I messed up. It's very explicit like that. So what I want is when we click, please request focus on the new label field, and that'll probably work. Build. And refresh. Main. Oh, this is not main anymore, Just. That's view, duh. Subscriptions. Okay, now I can click once, and then I can type, and I'm very happy. Happy person. All right, well that's it. That's a pretty darn useful application for the amount of time spent on it, with a lot of practice. And I'm pretty happy with this. In fact, I'd like to publish it. So one thing the Elm ecosystem, the Elm language system does not try to do yet is build pipelines. People just have to integrate Elm make into whatever. So personally, I am going to copy a script in that I frequently copy in. Okay, we'll commit that. Why are you not in there? Get in there. Okay, I'm going to copy this release script here, and I'm also going to bring in a README that I created just for you earlier. And while we're here, you can have the slides. And okay, we're going to add that. We're going to commit that. And then and push that up to master, I think. And then when I run my release script, it's going to create a GH-pages branch, and you'll be able to run this app on GitHub, because it's just JavaScript, right? I don't have a backend. But you can save if you wanted to save your diagram labels, you could totally just export your history. Super sneaky save mechanism. Oh, come on, it's not that big a PDF. Oh, okay, maybe the slides idea wasn't very good. Too late now. Yeah, whatever, we'll go look at some slides. Right. The one point that I automated a lot of those code changes, which conceptually is like saving me a lot of typing. Okay, that's not conceptual, that's just, it's like literally saving me a lot of typing. Conceptually, it's encapsulating operations where instead of making a change in one place, like in, this probably happens in Angular, but I've avoided Angular, but in Ruby on Rails and stuff like that, there's a lot of indirection and there's a lot of abstraction and there's a lot of magic going on to let you change add a field in one place and poof, it's in the database and poof, it's on the screen, and so that one conceptual change winds up being approximately one code change. And in Elm, that text input was 5 code changes, but I've abstracted that into one operation using my editor. So I get all the ease of writing, and yet I keep all the ease of reading. And by reading, I don't mean me reading the code. I really don't mean business people reading Cucumber tests. I mean me as a programmer who knows Elm, but nothing else. I don't need to know Rails and all its magic. I don't need to know the secret Angular spells. I can look at the code and tell exactly what is happening. So Elm is kind to people writing Elm, and Elm is kind to people maintaining Elm in the future. And I love maintenance, and therefore I like Elm way better than Ruby. So that's really cool. The state of Elm here, if you want to use it, it's totally good in the browser, and that's the only problem it's trying to solve at the moment. No Red Ink, they hired Evan, so they're the company that has the most production Elm probably, but dozens of companies have Elm in production. It's not weird. You wind up having to do a little bit of custom Java interop because not all the libraries are there. We talked about the build script, and I really want this to be available at YOW Brisbane, and that push happens, so now I should be able to run my release script. And then it will push up GH pages, and then that will be there very soon. If you're interested in code automation, because this Atomist rug thing works on every language, it is not specific to Elm, although I did make an Elm library to make my life a little easier. But there's a bunch of editors out there that work on Java projects and some on Clojure projects that are already published. And you can make your own because the CLI, it's designed to be used from Slack in a collaborative environment. But I don't trust Slack and the internet at a conference, no. So I run at the command line. Also, you can test your own at the command line. But you can check that out. I hope that this presentation has got you thinking about a different way to abstract code, maybe a little less afraid of functional programming, and a lot more resentful of runtime errors. And most of all, I hope that it's raised your standard for a language interface, because our interface with the language is not just the syntax. It's definitely the compile errors. It's also all the tooling. It's the entire language system. In Elm, if I want to write tests, I learn Elm test. I don't learn Mocha and Jasmine and Webpack and Gulp and all the incredible richness of the JavaScript ecosystem. Let's see, yeah, I work at Stripe and I podcast on Greater Than Code, and if you find me later, I have stickers for both of these and we'll be thrilled to give you one. That's it. This link should by now have all the tools that I used in this presentation, and this might even work, although GitHub pages, come on, do it, do it. Yes. Okay, and you can play with the app right now, it's online. Thank you.